Alrighty, so here's our problem. Determine the empirical formula of the compounds below. So let's look at A first. We see that it's 75% carbon and 25% hydrogen. So let's break down A. So 75% carbon and 25% hydrogen. Now, what's interesting and what's kind of intuitive is that these percentages add up to 100. We can now use that to convert our percentage to grams for the sake of easier calculation. So let's take the 75% and convert it into 75 grams of carbon. Let's take the 25% of hydrogen and convert it into 25 grams of hydrogen. And since we have that, let's also find the molar mass of both carbon and hydrogen. And if we reference our periodic table, we will see that the molar mass of carbon is 12.0 grams per mole. And the molar mass of hydrogen is going to be equal to 1.00 grams per mole. So, awesome. Now, since we know the grams per mole and we have grams, let's find moles. So, we're going to divide our 75 grams by 12.0, and that's going to give us 6.25 mole. These are going to cancel out. And so that's for carbon. And for hydrogen, we have 5 grams of hydrogen. 1 mole is going to be 1.00 grams of hydrogen. And this intuitively is just going to be 25 moles, 25.0 moles. So working with 3 significant figures based off of the periodic table. All right, so now that we have that, let's write down how much moles each of our elements have. And let's go even further with this. So, the reason why we're converting to moles is going to be a lot more evident when we start dividing by the smallest value given to us. And the reason why we're doing this, and carbon is going to have the smallest value of 6.25 moles. The reason why we're doing this is now when we divide 6.25 by 6.25, we're going to get a whole number of carbon being 1. If we do that the same thing with hydrogen, 25.0 moles, and divide it by the smallest value of the moles, 6.25, we're going to get 4 parts of hydrogen. So hydrogen is going to be 4 in this case. By using the smallest value, we set kind of a baseline for the smallest value of moles. So for carbon, our carbon is kind of like our baseline, our home base. We're using it as a reference to the ratio of other elements. And in this case, it's very clean. It's very orderly. It's going to be 1 part carbon for every 4 parts hydrogen. And that is going to be written as the empirical formula of CH4, which is a very common compound known as methane. And that is going to be our answer. So let's do a second one, where we're going to take one that has 3 parts to it. We're going to look at letter C. So let's look at C. So aluminum is going to be 22.1%, phosphorus 25.4%, and oxygen 52.5%. And does that add up to 100? Yes. So let's skip the step and just convert all of these to grams straight away. So we're going to have 22.1 grams of aluminum. We're going to have 25.4 grams of phosphorus, and we're going to have 52.5 grams of oxygen. And because this is a compound, we just have to assume it's elemental oxygen and not diatomic oxygen, unless it told us otherwise. So now that we have that, let's again reference the periodic table. And we can see that aluminum has a molar mass of 26. Let's round up to 3. We're gonna have 3 significant figures in this case. So on the periodic table I'm using, it says 26.98, but let's just make it 27.0. It's very close to 27, and rounding to 3 sig figs, we're just gonna get 27.0 grams per mole of aluminum. And then for phosphorus, it's going to be pretty much the same, because on my periodic table it's going to be 30.97, so we're just going to round that to 31.0 to 3 sig figs grams per mole of phosphorus. And then oxygen, probably know it by heart. If not, that's alright. It's going to be 16 grams per mole of oxygen. Alright, so now that we know that, we're just going to divide each element by its corresponding molar mass. So in the case of aluminum, it's going to be 22.1 grams. And divided by 27.0 grams per mole. And that is going to give us 0.819 moles. Then we're going to do phosphorus, which is going to be 25.4 grams divided by 31.0 grams per mole. And that's going to give us 0.819 moles. And then finally for oxygen, we're going to do 52.5 grams divided by 16.0 grams per mole. And that will give us, so I'm going to write it down here, it's going to be 3.28 mole. So let's transcribe these onto the side so we have them. So 3.28 mole, 0.819 mole, and 0.819 mole. Awesome. Now let's go to our final step. So now that we have the values, we're going to select the smallest value. And in this case, there's 2 of them have the same smallest value, so it doesn't matter which one you use, as long as you're using the smallest value. So in the case of aluminum, let's just say we're going to say aluminum. And it's going to be 0.819 mole divided by 0.819 mole. It's going to be 1. And then intuitively, phosphorus is going to be the same thing, 1. Now let's look at oxygen. So we have 3.28 mole, and we're dividing by 0.819 mole. And that is going to give us something that is very, very close to 4. It's going to be 4.004. So for the sake of rounding into an integer, because we need an integer for our empiric formula. You can't write something like you can't do CH2.5. You can't really have half an atom, so we have to use the nearest integer, and in this case it's 4.00, so it's just going to be 4. So now that we have that, we have 4 parts oxygen, 1 part aluminum, and 1 part phosphorus. We know that aluminum is going to be the cation in this case, and that phosphorus and oxygen typically make a phosphate group. So it's going to be written as aluminum with a subscript of 1, so we can omit that 1. Phosphorus, again, subscript of 1, so we don't need that 1. It can be omitted. And then 4 parts of oxygen. So we have aluminum phosphate. Let me double check. Yes, aluminum phosphate. All right, so that's going to be your answer. Aluminum phosphate is the mysterious compound given these percentages.